Hello everyone, hope you all are fine. Welcome to my YouTube channel. Today we will discuss kinetic gas equation. Kinetic theory of gases states that the molecules move randomly in the vessel. They collide with each other and with the walls of the vessel. This collision is perfectly elastic. When the molecules collide with the wall, they exert pressure. On the basis of these postulates, we will derive kinetic gas equation. Suppose the volume of a gas is enclosed in a cubic vessel. N are the number of molecules and m is the mass of each gas molecule. Let the length of each side of cubic vessel is L. Suppose a single molecule moves with the velocity u in x direction. It strikes the wall A and bounces back with the same velocity, but in opposite direction, so minus u. As we know that the momentum is equal to mass into velocity. Velocity in this case is u, so the momentum of molecule before collision is mu. As the collision is perfectly elastic, so the momentum will remain conserved. Momentum of molecule after collision is minus mu, that is minus sign is due to the opposite direction. So change in momentum is 2mu. After striking the wall A, the molecule travels distance L and it strikes the wall A bar and return to A again, covering distance L. So the total distance traveled by the molecule is 2L. And we know that the distance is equal to velocity into time. Velocity is u and distance traveled is 2L. So we can calculate time, that is 2L over u. Now rate of change of momentum, that is change in momentum per unit time. Change in momentum is 2mu and time is 2L over u. It will give rate of change of momentum, that is mu square over L. This is the momentum gained by the molecule when it strikes the wall A. The momentum gained by the molecule when it strikes the wall A bar will also be the same. So the total momentum in x direction is 2mu square over L. We can also calculate the momentum in y and z directions. Let's suppose that the velocity in y direction is v and the velocity in z direction is w. So the momentum in x direction will be 2mv square over L and the momentum in z direction is 2mw square over L. Total momentum in all the three axes is 2mu square over L plus 2mv square over L plus 2mw square over L. If we take 2m L common and the sum of u square plus v square plus w square collectively as c square, so the momentum will be 2mc square over L. For n molecules, it is 2mnc square over L. According to Newton's second law, rate of change of momentum is force. F is equal to 2mnc square over L. Now this c square, it is the velocity of single molecule. For n molecules, it will be c1 square plus c2 square plus c3 square and so on cn square, divided by the total number of molecules. It will give the root mean square velocity. So the force for n molecules will be 2mn c root mean square divided by L. This is the force. Now we will calculate the pressure. That is, pressure is equal to force over area. We know that the area of one side of cube is L square and a cube has 6 sides. So the total area of cube is 6L square. By putting the values, we get P is equal to 2mnc root mean square divided by L into 6L square. It will give P is equal to 1 over 3 mnc root mean square divided by L cube. Now L cube is a volume, so we will write V. P is equal to 1 over 3 mnv c root mean square. This is the pressure exerted by n molecules on all the walls of cube. If we shift the V to the right hand side, it will give PV is equal to 1 over 3 mn c root mean square. This is the final kinetic gas equation. Now what this equation tells? This equation explains the pressure, mass and volume of gas molecule in relation to their velocities with which they are moving. It also shows that the product of pressure and volume is 1/3 of mass of molecule multiplied by their mean square velocities. This is all about kinetic gas equation. If this lecture is helpful, please like the video and subscribe my channel.